Welcome back. This is video 2 of a series for using DUnitm. Where we left off last time was we had a single test case working, and we were ready to move on to the next section. So just to recap, if we have on our test cases here, we've got this is the test case that we ran. We wanted to confirm that the get concatenation function was working correctly. And we had 5 tests that we ran, and they were all running successfully. Now, one thing we've noticed once since we posted the last video is that the test summary is still showing at the top here. Now, that's not correct. So the first things first, we probably should fix that up. So you see that I've put the test summary call here and put the test case after it. So obviously that is not going to count in our summary. So I need to just move that down here, and we should all be good then. That should make much more sense. So we'll now run that again, and we'll see that our test summary actually counts correctly, that there was 1 test set, 5 tests, 5 passed, no failures, skips or errors. Okay, so that makes a bit more sense to start with. So where we were last time, we wanted to move on to the second function, which was this get double. So again, we can take a simple approach here. So we want to confirm that get double doubles a number. That's what the function will do. So we just go back up here, make a procedure, doubles a number, and begin, and we want to make a new case, pretty much the same as we did last time. We want to make a new case and a new test. So our new case here is we want to, again, we just want the text version of the thing above. So I might just grab that out. I wonder if there's, just thinking out loud here, I wonder if it's possible to get the name of the function at runtime using RTTI or something and extract, anyway, a digression there. May be possible. We'll think about that later. Okay, and our first test, we actually want to say an integer number doubles will be our test. So again, as we did before, our action is going to be something in the use simple test functions get double. We're just accepting a single value there. Obviously can't pass a integer, but we'll just make sure that our single, let's make the L value type single, is an actual integer. So L value here. We're going to need a result. Value, and we're going to have an expectation and a result. So let's set it up to our arrangement. We'll just say arrange. L value equals, so we want an integer. Let's pick a sensible one, like 5 or something like that. Our expectation is, we're expecting it to be 10, the result to be 10, and our result is going to be whatever we are, the result of our action. Okay, so our assertion, and I think we'll dispense with actually putting the TDD labels on here. It's not adding anything to what we're doing at the moment. So let's just make this here. Put that down there, and we want to assert by checking that is equal L expected, L result And again, we don't need to use the custom message or the skip function here. So we'll just use the default behavior, which is quite sensible. So again, using TDD, we're expecting this first time to fail because we haven't actually implemented get double, but we should see an outcome there. Oh yeah, if we close our previous one, that will work better. And we'll see that yes, we've got our first test set was confirm concatenation. Our second test set is the new one we're just doing, confirm get double, doubles the number. We're expecting 10, we've got nothing, so that's as we would expect. So let's get double, and double result equals a value times 2. Okay, so then if we run that, we're expecting that second one to pass, which it does now, and we've got 6 passing tests. Okay, so we probably want to do a few other things. So we maybe want to double some other kinds of things. Maybe so we're going to start with, say, 0, double 0. We're expecting that to be 0. Can't imagine we'd have too much trouble with that, except we need to describe our test. A 0 doubles to 0, of course. So we're expecting that to work, which it does. 0 doubles to 0. Yeah. 0 doesn't really double, of course. Then we want maybe a negative number, something like that, negative 35, and we expect it to be negative 70 if we double that. So pretty happy. Oops, better change it. We'll just change our description here. Negative numbers double. Numbers, I'm just making things up as I go along here. Our negative numbers double. So if we run the test now, our negative numbers double, which they do. So we're all happy. Now need to do some fractions and floating point numbers. So in this case, we to do something like 1.8, and if we double that, we're expecting to get 36, I think, if my math is good. 18, yep, that should work, and then we probably want to do something like negative 0.03, which we'd expect to double to negative 0.236, something like that. So we've done plenty of happy cases. The happy case worked pretty well. Floating point numbers doubled. 2 test cases for that, and we're all looking good. Now, so those are the happy path. What about the sad path here? Okay, what are we going to think about here? What could possibly go wrong here? Well, the most obvious thing that could go wrong is that say you have a number that when you double it is bigger than the variable can handle. So if we look in the documentation for how big a single can be, simple types, weighting, we go down to way down to single, and we can see that goes 1.5 times 10 to the blah blah blah. Okay, so if we grab out this number here, so if we expected to double that, that would be bad. We would expect that to not work, because obviously 6.8 times 10 to the 38 is bigger than the variable can support. So we'd expect that to produce some kind of overflow condition. So let's see if we can set that up. So first things first, let's try and set that number. So that L value, if we double this number, even 3.2 would be fine. E plus 38. And so we're not really expecting to get an answer back. We're expecting to get some kind of floating point issue. We're expecting to get some kind of exception. So what we can do here is we can set an exception, expect exception. Now I actually don't know what kind of exception it is, so I'm just going to leave that blank there. It can be overflow some kind, but I'm not quite sure what. So I'm going to say expect exception. Actually, what I'll do, I'll actually leave it out. By default, the framework will actually say, well, you haven't set any expected exceptions. So it will assume that the nil exception by default. And well, so when we run that, we'll get some kind of exception. It'll tell us what kind of exception is. We'll be able to use that in our testing. Okay, you might not have been able to see that, but very, very quickly ran up and actually got an exception on the screen, but it didn't trap it, obviously. So what we're going to need to do is wrap that in an exception handler, otherwise we'll never see the message. Try except, and we want to now test for that condition. So if we say on E exception do, and we want to check that the passed in the exception is the one we're expecting. So at the way it is right here, we're not telling it what exception we're expecting. So it'll just assume the nil exception. So that's a pretty good point to start. So at least we'll get a message from the system, from the framework, telling us, well, actually you expected nil, no exception, but you got one. Here's what it is. So let's see what happens when we run that now. Okay, now at least we get our screen trapped, and it's telling us you're expecting no exceptions, but you actually got this E overflow, floating point overflow exception. So E overflow is the class name, and floating point overflow is the message. So what we'll do is we will get that class name and tell the framework that that's the class of exception that we're expecting. So we need to set that sometime before we call the actual function, otherwise it won't know what we're expecting. So what we have to say is, in the framework we say expect exception and the class name of the exception. Now the class name is not quite right, so you can actually put the part of the message, any part of the message or the class name in the expected exception, but the class name is preferred because we don't want in different languages for our program, for our test to not work just because it's in, say, French, which obviously if you're looking for the English version of the exception, you won't see that. So class name is better. So now what we're hoping is that we're telling the framework, look, we expect this to get a floating point exception. Just check that that is the exception that we get. And if it does, well, then our test is good and we want it to pass. So let's now run that and see what we get. Okay, this is exactly what we want. We've got a blue indicator here saying very large floating point numbers do not double because they give you an exception. But it's the exception that we want. So that's a passing test. If for some reason we got a different exception than we were expecting, we would get a similar message to the one we had before. So if, say, we mistyped that and then ran that again, we actually got, oh, you're expecting E overflow, but you got E overflow. And obviously that's not the exception we're expecting. So I think that's all pretty good. So next we want to test some more conditions. So we want to check, for example, if we've got very large floating point numbers, what about very small ones? So we'll need to investigate that next. So for very small numbers, we'd expect to have something pretty similar to this. So let's just copy this down. And we want very small floating point numbers do not double, which we would expect since we have very small number that's beyond the range of the single value there. So let's go and see what value we're actually looking for. Now, so single, it's 1.5 times 10 to the minus 45. Now, it's a pretty small number. It's really small, actually. And intuitively, first thing you might think about doing is saying, say, 1.2. Again, because we're looking at smaller than, we might say something like this, and we'd expect to get the same kind of outcome as we did before. So without thinking about it too hard, let's give that a go. We're expecting that to just work, right? So we've got the very large, but the very small is not showing. Why is that? Now the reason must be that we're only doing a framework check just here and not inside here. So the only conclusion you can say is, so it must not have failed. So in that case, we're expecting an exception. We didn't get one. So, well, if we get past here and we haven't thrown an exception, well, that's a fail. So let's check for the nil exception here. And see what we get when that happens. Okay. So, now we've at least got a message saying, okay, we've got very small floating point numbers, do not double. We expected an overflow, but we got the nil exception. Now that's a nil exception we actually just passed in. So what does all that mean? While we're thinking of it, obviously we've got the same up here as well. Fail the test if that doesn't work. So exactly in the case we had for the small, we're expecting an exception, doesn't happen. We want to catch that it didn't happen. So we want it to fail if we didn't get an exception. So why aren't we getting an exception on here? You expect that negative 1.2 times 10 to the minus 45, you double that, that's got to be beyond the range of the floating point calculation, doesn't it? In fact, what that is this is the testing framework telling us that our assumption about what we understand the test to be is wrong. It's saying you expected this to fail, and I really did expect it to fail because just without thinking about it too hard, doubling the really small number would expect, in fact, doubling it with a negative number would expect to give us an overflow. But it didn't. What happens if we make that a not negative number? Does it then work? Nope, still gets a nil exception. So, so the thing we thought we knew about what this overflow condition was is not really the case. Okay, so now what we want to do is something like getting the get double function itself to say, look, no, I can't handle that number. I'll raise an exception so that the user of the function doesn't get the wrong impression that the number that has been passed in is actually sensible. Okay, we could say something like this. If absolute value of a value is smaller than 1.5 e minus 45, then raise exception, create a number too small to double. We could try something like that. Okay, and if we do, what do we get when we run that? Nothing. Okay, so what does that tell us? So something's going wrong. This is the advantage of using unit testing. What we've done here is we've actually changed the behavior of our function, and now some of our earlier tests that were working are now failing. So let's have a look and see if we can work out what it is. Okay, so the simplest way is just run that at the command line. Let's see what we can get. Test simple functions, and we're getting the first test case, the second, and then we're getting the exception, number too small to double at some earlier point. Now, the people will be laughing at me going, what about your case where it's 0? Yes, absolutely right. So the case where we're checking for 0 is obviously less than that. What we need to do is check for the condition between, if it's bigger than 0 but less than this number, then obviously that's the condition we want to check for. So let's say a value is greater than 0 and the absolute value is less than 1.45. We know that range can't cope. Now I'm just a little bit concerned that maybe the compiler should be able to cope with that number, since that it was said it was that limit, and it can certainly handle 0. So I think we'll detect that condition. Just not quite sure what the compiler will do if a number is in between that. Will it be able to tell it's in between that because it's so imprecise? I don't know the answer. We'll just run it and see what we get. And okay, so we're expecting an E overflow. We're not expecting that anymore. We're getting a number too small to double. Okay, this is perfect. So we actually now can check for this number too small to double. Ideally, we'd actually make a new exception class and check for that. But just to demonstrate that you don't actually need to do that, if we just search for the text number too small instead, and so that's what we actually want to check for. We know we are not getting the overflow exception. We're going to get instead our custom exception, which is number too small. So we don't have to have it precisely the same. You could actually have number 2 or number too small or just too small. But whatever distinctly identifies or uniquely identifies the exception is all we want to do. Okay, so now we should be good, and we should be getting past very small and floating numbers do not double, which gives us an exception. So that looks now perfect. Okay, that seems like a pretty good place to stop for this video. We'll come back in the next video in the series, and we'll use that one last function to demonstrate how you convert this simple test run into a project that has a standard test run. So we'll see you in the next video.